In this video, we're going to talk about how to simplify cubic roots. Cubed roots, these are pretty simple. It's the same concept as a square root, except instead of having two of the same numbers multiplying to get something, we need three. So we need three of the same numbers that multiply to get to 27. So 3 times 3 times 3 equals 27. So the cubed root of 27 is 3. For 64, you have 4 times 4 times 4. So the cubed root of 64, the cubed root of 64 is 4. For 1,000, 10 times 10 times 10. And then when we have variables into our situation, any variable, any exponent that is divisible by 3 will be a cubed root. So x to the third is divisible by 3. So the cubed root of x to the third is x, because x times x times x is x to the third. So that's just x. So x to the third is once again, in the next one, is once again a cubed root, is a perfect cube, sorry. So we could take the cubed root, which is x. 6, the exponent of y, is also divisible by 3. So 6 divided by 3 equals 2. So the cubed root of y to the 6th is y squared. The next one, 8x to the 6th, y to the 3rd. The cubed root of 8 is 2. And then 6 divided by 3 is 2. So x squared. And 3 divided by 3 is 1, so y. Sometimes there's a situation where the numbers are not necessarily a perfect cube, because they don't always have to be. So, and just to make this a little bit more, so I can just explain something else, if I were to make that 2. Since 2 is not, I forgot my cubed roots here. So since 2 is not a perfect cube, I can't do anything with it. Since 7 is not divisible by 3, I can't just take that out of something. But what I can do is I can change it into x to the 6th times x. And the reason I'm going to do that is because 6 is divisible by 3, like we've been doing. So the cubed root of x to the 6th will be x squared. So I can take out the x to the 6th as x squared, and then I still have my cubed root, and then inside here I have 2x left. So now for the second to last one, 9 is divisible by 3, so 9 divided by 3 is 3, so x to the third on the outside. Now 14 is not divisible by 3, but what is the closest number that is to 14? 12. So if I can turn this into y, let me just make this into an extra step so we don't get confused. So I'm going to turn this into x to the third cubed root of y to the 12th times y squared. Because don't forget, when we multiply when we multiply two things with the same base, we add the exponents. So 12 is divisible by 3. So 12 divided by 3 is 4. So y to the 4th is the cubed root of y squared. So what we have at the end, our final answer, x to the third, y to the 4th, cubed root of y squared, because we cannot do anything else with this. And for the last one, move that as well. All right. So 13, x to the 13 is not divisible by 3. So what I can do, is I'm just going to change it like I've been changing things. So I can change x to the 13th into x to the 12th times x to the first. Y to the 14th, the closest thing that's divisible by 3 is 12. So I can make this y to the 12th times y squared. And z to the 16th, the closest thing is 15. So I can make this z to the 15 times z. Now I did all of this, so I can now simplify. So these are now my perfect cubes. So 12 divided by 3 is 4. So x to the 4th. Y to the 12th. 12 divided by 3 is 4. So y to the 4th. 15 divided by 3 is 5. So I have z to the 5th. So that's all on the outside. I still have my cubed root, though, because these terms that are left inside are not perfect cubes. So I can't do anything with them. So I'm left with this. All right.